everyone, Mike Bushell here, creator of Crumb. I'm thrilled to announce that version 1.3 is now live and ready to download on Steam. I've completely re-engineered Crumb's simulation backend, opening up incredible new possibilities for building larger and more complex circuitry. It's now possible to run up to 96,000 Hz in certain setups with ample processing power left over. This means precise, high-speed simulations across both digital and analog applications. To showcase this new update, I'll be demonstrating Crumb by simulating something complex and fascinating, the legendary Ben Eater 8-bit CPU. Before diving into today's demo, I highly recommend checking out Ben Eater's channel and his website if you haven't already done so. His tutorials on building an 8-bit CPU from scratch inspired Crumb's creation, and it's been a huge inspiration and influence on me personally. Ben offers a fantastic step-by-step guide in building an 8-bit CPU from scratch, and Crumb is the perfect platform for building a complete working simulated model. It only took me a few weeks to build and test my own CPU using Crumb, and I encourage you to try it too. It's an amazing way to deepen your understanding of electronics. Rather than doing a full step-by-step guide on doing the CPU build, I'll jump straight into using the Arduino to program the microcode instructions into the CPU. Then we'll run a simple program together for the first time. So here is my Ben Eater 8-bit CPU. As I said, I'm not going to go over step by step how it was built, but as you can see all the structure of it. I've made my own little tweaks and changes to wiring and some position of components. Down here we've got our microcode EEPROMs, and when we look inside we can actually see some of the data that's in there. And the way that I programmed the EEPROMs was I built one of Ben Eater's other circuits, which is an Arduino connected up to a shift register to program the EEPROM. But be sure to check out that video so you get an understanding of how it was done. So at the moment the CPU is doing nothing. At the moment in memory there is just a whole load of zeros. So that is just a no operation command, so literally it just runs through the program counter all the way right back round to 0 again. So if we come over to here, I've already written out a simple program which is here, and we're going to program that into the CPU using these dip switches. And what it's going to do is load a value into the A register, output it on the display, and then we're going to add another value to the A register, and we're going to output that again, and then we're just going to jump straight back to the addition. So hopefully we should just have a value which just keeps adding numbers until infinity until we turn it off. So I'm just going to go ahead and program that in. Okay, that's all programmed in now, and what I'm going to do, I'm going to hit reset here, so everything's cleared, and what can be seen on the RAM is our first instruction, which is programmed in. And what we'll do, we shall start the clock and we shall see what happens. So there we go, we've got an 8 come out on the output, and we've added a 4, and again we should add another 4, and it will keep running and running. And what we can do, we can speed up the clock by using the potentiometer, and here we go, we should really get things moving. And there we go, we can look at all the LEDs, we can see the data which is on the bus, the program counter running through, the data which is going into the A register, the sum register here, the B register, all the values in RAM, memory instructions, and then a microcode counter down here and microcode instructions. So there we go, that's a fully working Ben Eater 8-bit CPU running in Crumb. At the moment this is running at 300 Hz, that's more than enough to be simulating everything. And we can even have a quick look inside the wires to see what's going on. It really gives a great insight into just the complexity of all the electrical transmission inside this big circuit. And if you want to do even more analysis, we can have a quick look at the logic pins as well, so we can see what's going on with every pin on every chip. And just, yeah, it offers a great level of analysis. So there we go, that's just going to keep running around until it gets to 256, and we're going to run out of space in our CPU because it goes up to 8 bits. But it would be great to see if anyone can expand on this, maybe make a 16-bit CPU. You know, feel free to add more instructions into the Arduino to program. At the moment, if you look inside it, all I've got is you know, just 6 basic instructions: no operation, load A, add, jump, out, and a halt command. But we've got lots of other space you can program in, and I've already defined where I've connected up all of the control signals. So yeah, feel free to change and use as you wish. Thank you for watching, and I hope it will inspire you to use Crumb to reach out into the world of electronics. Be sure to subscribe and keep an eye on our social pages for more updates in the future.